Clap, 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 clap your hands. Just say the word. Clap, 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 clap your hands. Learning paths. Yeah. We have the second area in the introduction to defensive security, areas of defensive security. Okay. Right, let's see. In this task, we will cover two main topics related to defensive security. Security Operations Center, SOC, SOC, where we cover threat intelligence and digital forensics and incident response, DFIR, digital forensics and incident response, where we also cover malware analysis. Security Operations Center, SOC, a Security Operations Center. I always say operation in a singular word. It's Security Operations Center. In my mind, I always go to Security Operations Centers, but it's Security Operations Center. Is a term of cybersecurity professionals. Is a team of cybersecurity professionals that monitors the network and its systems to detect malicious cybersecurity events. Some of the main areas of interest for SOCs are vulnerabilities. Whenever a system vulnerability, in other words, a weakness, is discovered, it is essential to fix it by installing a proper update or patch. When a fix is not available, the necessary measures should be taken to prevent an attacker from exploiting it. Although remediating vulnerabilities is of vital interest to a society of centers, security operations centers, it is not necessarily assigned to them. Policy violations. We can think of a security policy as a set of rules required for the protection of the network and systems. For example, it might be a policy violation if user starts uploading confidential company data to an online storage service. Jesus Christ, if that happens. Unauthorized activity. Consider the case where a user's login name and password are stolen, and the attacker uses them to log into the network. SOC needs to detect such an event and block it as soon as possible before further damage is done. Network intrusion. No matter how good your security is, there is always a chance for an intrusion. An intrusion can occur when a user clicks on a malicious link or when an attacker exploits a public server. Either way, when an intrusion occurs, we must detect it as soon as possible to prevent further damage. Security operations cover various tasks to ensure protection. One such task is threat intelligence. In this context, intelligence refers to information you gather about actual and potential enemies. A threat is any action that can disrupt or adversely affect a system. Threat intelligence aims to gather information to help the company better prepare against potential adversaries. The purpose would be to achieve a threat-informed defense. Different companies have different adversaries. Some adversaries might seek to steal customer data from a mobile operator. However, other adversaries are interested in halting the protection in a petroleum refinery. Like my biceps, it's a petroleum fast in there. That can be understood wrongly. Example, adversaries include the nation-state cyber army working for political reasons and a ransomware group acting for financial purposes. Based on the company, which is the target, we can expect adversaries. Okay. Intelligence needs data. Data has to be collected, processed, and analyzed. Data collection is done from local sources, such as network logs, and public sources, such as forums. Processing of data aims to arrange them into a format suitable for analysis. The analysis phase seeks to find more information about the attackers and their motives. Moreover, it aims to create a list of recommendations and actionable steps. Learning about your adversaries allows you to know their tactics, techniques, and procedures. As a result of threat intelligence, we identify the threat actor, which is the adversary. Predict their activity, and consequently, we will be able to mitigate their attacks and prepare a response strategy. Okay, let's go back it up. Okay, so security operations centers. We are in the defensive part of security. We talked about offensive security and penetration testing. Now we are at the security operations centers and digital forensics and incident response. They have different purposes. Now, let's see. Areas of interests for security operations centers, or let's say in other words, things that they do if you want to to take part of this kind of activity, right? They let's say log vulnerabilities. They watch out for vulnerabilities in a system. They watch out in terms of discovering the vulnerability as soon as possible, and also remediation. That's very important. This keyword is very important. They seek to remediate the issue. Policy violations, security violations, right? When well, in this case, it's just uploading confidential company data to an online storage service. Each company has different policies. Maybe this is one reason for it. Okay, unauthorized activity. Well, again, as you can see from the example, the stolen data from a user that, let's say, uses a specific service, and another guy logs with that information and do a lot of stuff. Now, of course, if you are the user that works for that company, the damage can be much worse than when you stole the, let's say, the credentials of a user that uses your application. It depends on what kind of, let's say, authority you have on the application. Networks intrusions. I mean, of course, you can find a vulnerability, let's say, or a weakness in any kind of systems. It depends on how much time you have and what you want to gather. Now, these are, let's say, the day-to-day, or not necessarily the day-to-day, are the highlights of this team, let's say, of cybersecurity. Also, threat intelligence, the protection that security operations centers employ in order to, let's say, defend from various weaknesses. Threat intelligence, the information gathering part, which is very important also in red teaming. The threat intelligence, basically information gathering about the vulnerability in order to know more about it and prevent for future breaks or whatever. I know that I saw somewhere a very good summary of this. Yes, here. As a result of threat intelligence, identification of the weakness, predict the action, and defend. Identify, predict, and prevent. The best words that we can use. Okay, let's go to digital forensics and incident response. This section is about digital forensics and incident response, and we will cover digital forensics, incident response, and malware analysis. Digital forensics. Forensics is the application of science to investigate crimes and establish facts. Of course, we all heard about forensics in real life when, let's say, a crime happened. With the use and spread of digital systems, such as computers and smartphones, a new branch of forensics was born to investigate related crimes. Computer forensics, which later evolved into digital forensics. In defensive security, the focus of digital forensics shifts to analyzing evidences of an attack and its perpetrators, and other areas such as intellectual property theft, cyber espionage, and possession of unauthorized content. Consequently, digital forensics will focus on different areas such as file systems. Analyzing a digital forensics image low-level copy of a system storage reveals much information, such as installed programs, created files, partially overwritten files, and deleted files. System memory. If the attacker is running their malicious program in a memory without saving it to the disk, taking a forensics image, a lower copy of the system memory, is the best way to analyze its contents and learn about the attack. We'll do that. We will do that in some rooms on TryHackMe. System logs. Each client and server computer maintains different logs files about what is happening. Log files provide plenty of information about what happens on a system. Some traces will be left even if the attacker tries to clear their traces. Network logs. Logs of the network packets that have traversed the network would help answer more questions about whether an attack is occurring and what it entailed. Incident response. An incident usually refers to a data breach or a cyber attack. However, in some cases, it can be something less critical, such as a misconfiguration, an intrusion attempt, or a policy violation. Examples of a cyber attack include an attacker making our network. Examples of a cyber attack include an attacker making our network or systems inaccessible, defacing, changing the public website, and data breach, steal the company data. How would you respond to a cyber attack? Incident response specify the methodology that should be followed to handle such case. Okay. So incident response is basically how do you respond if you are dealing with a cyber attack. Right? Yeah, that's it. The aim is to reduce damage and recover in the shortest time possible. Ideally, you would develop a plan ready for incident response. The four major phases of an incident response process are preparazione. This requires a team trained and ready to handle incidents. Ideally, various measures are put in place to prevent incident from happening in the first place. Detection and analysis. The team has the necessary resources to detect any incident. Moreover, it is essential to further analyze and detect incident to learn about its severity. Containment, eradication, and recovery. Once an incident is detected, it is crucial to stop it from affecting other systems, eliminate it, and recover the affected systems. For instance, when we notice that the system is infected with a computer virus, we would like to stop the virus from spreading to other systems, clean the virus, and ensure proper system recovery. As you can see keywords which are easily understood and perfectly placed in certain so next write to certain words that maybe suit better, or maybe just you understand better what the initial phrase is about. Post-incident activity. After successful recovery, a report is produced and the lesson learned is shared to prevent similar future incidents. Pretty cool. Right, so here we have a graph. The first phase, preparation, detection and analysis, which will loop with containment, eradication, and recovery. And here we also have post-incident activity, which goes all the back to preparation, and you do this process again and again. So this process is done all the way for every kind of incident that you handle. Malware analysis. Malware stands for malicious software. Software refers to programs, documents, and files that you can save on a disk or send over the network. Malware incidents may... malware includes many types, such as viruses. Virus is a piece of code, a part of a program that attaches itself to a program. So a virus basically is just a piece of code that is attached to a program. It is designed to spread from one computer to another. Moreover, it works by altering, overwriting, and deleting files once it is infects a computer. The result ranges from the computer becoming slow to unusable. Trojan horse is a program that shows one desirable function but hides a malicious function underneath. For example, a victim might download a VGO from a shady website that gives the attacker complete control over their systems. Ransomware is a malicious program that encrypts the user's file. Encryption makes the files unreadable without knowing the encryption password. The attacker offers the user the encryption password if the user is willing to pay a ransomware. Malware analysis aims to learn about such malicious programs using various means. Static analysis works by inspecting the malicious program without running it. Usually this requires solid knowledge of assembly language, which is what processors instructions are. In other words, computers' fundamental instructions, computer language, machine language. Binary language. Dynamic analysis works by running the malware in a controlled environment and monitoring its activities. It lets you observe how the malware behaves when running. Let's go, boys! Okay. I don't know what's wrong with me. Anyway, let's see the questions. What would you call a team of cybersecurity professionals that monitors a network and its systems. For malicious, that's how you buy more time to answer questions. Okay, what would you call a team of cybersecurity professionals that monitors a network and its systems for malicious events? Security Operations Center. What does DFIR stands for? And I presume that if you click here, you will see. Oh my god, digital forensics and incident response. This is funny. Thank you. What kind of malware requires that the user to pay money to regain access to their files? Can you remember that? Can you remember that? Let's see what happens if we say this. Oh damn, whoop whoop, the answer is correct. It would be funny if they changed this one, like a random kind of onomatopoeic phrase. All right,